So the first speaker is Heng from End Group, and he will talk about the TuGraph implementation of the LDBC social network benchmark.
Thank you. We pronounce it TuGraph. Tu is in Chinese, it's about graph, so we call it TuGraph. Yeah, and
graph.
Yeah, graph. Yeah. So whatever you are China or in English, it's graph. So today I want to share something about the LDBC SNB implementations. We know it's TuGraph is top the SNB ranking, and I will give some implementation insight. I think it's something I want to say before. TuGraph called TuGraph DB, and it is a performance-oriented graph database, but it's implemented on single machine. We doesn't choose sharding, and he supported full ACID with serializable isolation and integrated with query analytics and learning. Also we implemented the OpenCipher API, and we plan to implement ISO-GCO in this September. And we also has stored process with C++, Python, and Rust API. And it is open sourced. Oh, it's long. It's 2022, last year. It's also open sourced. And what we do to TuGraph, we have I want to reference a few days ago. Don Trumbullin, he said, why are SQL too reliable? One important thing is it has high quality open source implementation. We want to make a TuGraph high quality open source implementation. And I list some of the design here. Many of them are common. The query implementation, we use metallized view and interquery parallelizing. And when using come to transaction, we use lock-free rate transaction and multi-version B+ tree. And underlying of TuGraph is LMDB. And when it comes to topology, we use adaptive continuous packing. I will explain it later. And when you use the topology, so it's some order of the edges, we use the property value-based sorting. Using property graph, so the properties we use compact layout. I also want to explain it later. And the last we compress with fixed and variable length data. It was very compact, so it saves some storage. Here we come to adaptive continuous packing. We know the underlying storage, when it is a new project, it's user chained. It comes a new edge or new vertex. It has a pointer to point it, and using pointer to connect vertex and edges, it has a fast write, but it will also comes a lot of random access. And some other TuGraph DB, like Nebula GBase, and it uses discrete KV. So each vertex or each edge is a key value. So it is relatively fast write, but sacrifices the skin performance. Following the scenarios in our Ant group scenario and also in SNB, we found that we get more read than write. So it's about 10-to-1 in LDBC SNB. And so we thought we should be faster read, and it's more important. And the second observation is the access locality of certain vertex edge. When we visit one vertex, we also want to visit all his out edge or all his in edges. So the edge should be in the same place so we can access it sequentially. And the last is power distribution and the degree of different vertices different. I write the 3 observations, 1, 2, 3, and we use some techniques, and also has the results behind. I will explain it one by one because we packed it into key value. So the key is vertex, and the value is edges. So the first is read-write 10-to-1, right? So we repack data while writing. When we write the data, we read all the value of the vertex and repack it very compact. And by this way, we have some cost while writing, but when we read it, it will be faster. And the second is access locality. So we continuously pack the edges in one block. When we do the scan, it will be faster. And the last is the power law. So some vertex has more edges and some has less. So when it is a small vertex, all his edges can be packed in a one value of his vertex, and when it is hub vertex, we split value of multiple blocks and also stored in the KV with multiple key values. So when we do the repack, we only have to access one small piece of value. We do not need to repack all the edges of a hub vertex. Maybe it's a late slowdown of hub vertex, but it's okay because we choose to the pack, and the pack size is about the page size of the system. Constantly, or I will use 4 KB. And this is the adaptive continuous packing. Another thing we use compact layout. Compact layout means where we put the property. We can put the property in separated key value, but also we can put the property in the same value of a vertex, just a side of the edges. And we compare to the implementations that we found in the query. So during the traversal, one or more properties of vertex or edges will be accessed. So we think put it together will be better to have the locality. And in the implementation of TuGraph, we choose the compact layout. And by use, we also know that if the value is very, very large, and it will be access too much unuseful data, and we will improve it in the future. And here's LDBC SNB interactive audit. I only noted the ranks first. And TuGraph has the audit 3 years earlier. It's 2020. It comes first, but 2 years later, and Galaxy Space he do some implementation, and he almost twice the top performance. And after 3 months, TuGraph do another audit, and it is top. About 5 months later, because we want to try to graph on the ARM-based architecture, we do another audit, and it has higher throughput. But the higher throughput mostly comes of a better server. Yeah, so the server is better and the throughput is higher. And TuGraph now is ranks the first in the overall throughput, but we hope and any other graph database will do the implementation. It's very welcome. And here's some details of TuGraph's implementation, and this is a roadmap for TuGraph. We have done here we have open sourced the last year and do cloud deployment, and have Python interface. In this month we just done the same thing epoch in Neo4j. And in the following, we want to do the HA. It is high ability support. It is just like we are not planning to do the sharding, but we think it's high availability is also important. And in the September or October, we will do the ISO-GCO. And when goes the next year, we will improve our storage engines. Yeah, so the following is our open source link, and Graph Analytics is also another project. It's about data flow, and it will be integrated to our DB in about half a year, and it's open sourced. And welcome for everyone to FreeTrail. Here's the link. It's FreeTrail in Alibaba Cloud. And thank you. Have any questions? Okay.
Please walk up to the microphone.
Great news to see your plans for the GQL implementation. And going back to something that was discussed earlier in terms of other parties who are looking at working with GQL and doing implementations, however, whether it's just at the grammar level or deeper than that, your open source approach, would that potentially extend to things like a equivalent of the Cypher test compatibility kit, the TCK? Are you open to working with other companies and projects in terms of tooling for language tooling for GQL?
So currently we just plan to implement ourselves, because we have another distributed graph database, and we want to uniform interface. And before I'm not quite familiar with tooling. Maybe we can give me more information. So I will if
sure. We could follow up on that. Yeah. Great. Thank you.
Your LDBC audited results are using the store procedure API.
Yeah.
Have you tried doing it with the OpenCypher implementation?
Oh yes, but here's it's about 10,000 users currently. But if we use OpenCypher, it's about 100. It's much slower, but we didn't tune it very well. And maybe we can tune it, but I think ISO-GCO is more important. After we implemented ISO-GCO, we will do the fine-tuning in ISO-GCO.